it's the Tuesday before the semester, fall 11 is starting, and I hadn't recorded a video in about a year, so I wanted to practice to make sure I knew how to work the equipment. And I wasn't terribly happy with my lecture for section 1.3, so I'm going to lecture on section 1.3. There's nobody in the room with me, so I'm essentially talking to myself. If you have questions on section 1.2, all of a sudden they're not going to appear on this video, which will make it, in some sense sucky. But I'll do my best. Hopefully I don't make any mistakes. There's definitely the chance that I make some sort of mistake. So if, as you're watching the video, you're convinced that I made a mistake, then I possibly did. So each of the problems in section 1.3 has asked me to factor a trinomial. Trinomial means there's going to be three terms. And anytime I'm asked to factor a trinomial, the first thing I want to do is look for common factors. So the very first thing I'm going to do is, for any of the problems in this section, is I'm going to factor out the greatest common factor when needed. And the problems in this section are set up into two groups. In problems 1 through 16, there aren't any GCFs. So this step, I'm going to skip this step for problems 1 through 16 because there aren't any GCFs. But in problems 17 through 24, I'll need to complete this step. Each one of those, the problem needs to have something factored out before you get into the factoring. Once I get the problems, the greatest common factor factored out when it's necessary, two, is I'm going to set my parentheses up. I'm going to set my parentheses up. That means I'm going to insert the signs. And in section 1.2, hopefully I discussed how to get the signs in your parentheses. If I didn't when I filmed these videos a few years back, I will when I do section 1.2 this semester. So if you're watching the old version of the video, you'll be able to tell because the quality isn't as good. I might have not discussed what signs need to be put in the parentheses, but so I'll give it to you here. So basically, I'll look at the signs in my original problem, and that's going to help me determine the signs in my answer. If the signs in the original problem are both plus, that's the easiest situation. My answer can't have anything but pluses. So I'm going to make two parentheses, and inside those parentheses I'm going to put pluses. I'm not going to finish this problem, but if I look at problem number 1 in this section, it's 3x squared plus 10x plus 7. This is the situation where the problem itself has nothing but plus signs. The signs in the problem are plus and plus. So if I was going to solve this problem, which I will eventually, or may eventually, my parentheses are going to get a plus and a plus. At some point, I'm going to say that I'm going to add to get the middle term, but that's going to come a little bit later. I just want to get the signs in right now. The second scenario that might come up to me is that the first sign in the original problem is a minus, and the second sign is a plus. And in the homework, I see that problem 6 has that set up. If I look at problem 6, I see 5x squared. First sign is a minus, and then I see 17x, second sign is a plus, plus 12. So this is this situation where the first sign is minus and the second sign is plus. And it's so tempting to want to put 1 plus and 1 minus when the problem itself has 1 plus and 1 minus. But when I go to factor this problem, both my signs have to be minus. So if I was completing problem 6, each of my parentheses is going to have a minus, and somehow add is going to be a key word. When I get actually into factoring problem 6, I'm going to add as opposed to subtract to figure out the lasts. That's 2 of the 3 situations. The next 2 situations are going to have parentheses with 1 plus and 1 minus, and kind of out of room on this page. So let me just kind of slide this up a little bit and see what I can do here to make it all kind of appear at the screen at the same time. So another situation that I could have that is different is a problem where the first sign is a plus and the second sign is a minus. As I glance through the homework quickly, problem 12 jumps out at me to have that sort of situation. Problem 12, when I look at it, I see 4x squared plus 4x minus 15. So the first sign I see in the problem is a plus. The second sign I see in the problem is a minus. When I go to get this problem started, I'm going to make my parentheses with their signs, and the signs in this parentheses are going to be 1 plus and 1 minus. And when I get into physically doing problem 12, somehow the key word is going to be subtract as opposed to add. And I'll talk about those keywords more when I physically do the problems. Just for now, I want to worry about getting the parentheses set up properly. The last possibility for the signs in my original problem is the first sign could be minus and the second sign can be minus. And as I quickly glance through my handout, problem 10 has that set up for me. When I look at problem 10, I see 8y squared minus 6y minus 5, so that the first sign is minus, the second sign is minus, and when that is my situation, my answer, one parenthesis is going to have a plus, the other parenthesis is going to have a minus. So when I go to factor number 10, I'm going to get one parenthesis with a plus, one with a minus, and again, when I physically do these problems, subtract is going to be my keyword. So for any problem in section 1.3, I see if there's a greatest common factor that needs to be factored out. None of the problems from 1 through 16 have that. Once I get the greatest common factor factored out, or if there isn't a greatest common factor that needs to be factored out, I set up 2 parentheses for my answer, get the signs in. Now I'm going to get to the additional steps, how to finish this, and depending on where you went to school and how you were taught factoring, you might have learned a method that's different than the method I'm going to teach. If the old video still exists of my lecture from section 1.3, I used to teach a different method. I'm going to teach how to factor using bottoms up. If the 4 problems I wrote down, you already know how to factor those problems, then you really don't need to watch the video because the video might not do anything but confuse you. My goal is, if you don't know how to factor these kinds of problems easily, my goal is to teach you a method that I can teach in a class period that is real effective. So what makes these problems in section 1.3 different than the homework in section 1.2 is the number in front of the squared term. Every problem in section 1.3, if you glance at it, it has a number in front of the squared term. That makes the problems harder to factor. If there wasn't a 3 in front of the x squared in problem 1, or if there wasn't a 5 in front of the x squared in problem 6, then I would treat the factoring like I did when I lectured on section 1.2. But the numbers in front of the squared terms forced me to use this different strategy. And the strategy that I'm going to teach today is bottoms up. So I'm going to start my step 3, and in step 3 I'm probably going to do some of the problems. So step 3, I'm going to begin bottoms up factoring. And again, if you know how to factor the 4 problems that I wrote down already, then, and you use a different method, then your method is fine. You don't need to learn a new method to make me happy. If you get an answer right, generally, there isn't a way to get an answer right by doing bad math, although occasionally that happens. So especially in factoring, if I present a factoring problem on the test and you factor it correctly, you don't have to use my method and you still get full credit. So bottoms up starts by doing this. I'm going to multiply the first and the last number in the problem. For instance, if I was looking at problem 1, the problem is 3x squared plus 10x plus 7. I'm going to multiply the first and the last number in the problem. The first number in the problem is 3. The last number in the problem is 7. I'm going to multiply that 3 by 7 and then get 21. And I'm going to rewrite the problem. Should have written my parentheses with my signs, but I'll get those down in a second. I'm going to rewrite the problem without a number in front of the x squared, and I'm going to change the 7 to a 21. So bottoms up factoring, it temporarily takes the number away from the x squared term. Because I multiplied by 3, at some point I'm going to divide by 3, but not right away. So that's the beginning of bottoms up. I multiplied the first and the last number, and I rewrote the problem without a number in front of the x squared, and I changed the last number to what that multiplication came out to be. Now I'm going to factor this. So I know what my signs need to be to factor this from that template that I wrote down for problem 1. I said this problem, 3x squared plus 10x plus 7, is going to factor to have a couple pluses. Even when I transform the problem by making the 3 incorporated with the 7, I'm still going to get the same signs, plus and plus. So now I have the signs. And hopefully from yesterday's lecture, or section 1.2 lecture, you quickly know how to get the firsts. To get the first, I'm going to split the x squared between the 2 parentheses and make an x go in each of the first positions. Because x squared is in the first position, I divide the exponent by 2, I get x to the first that needs to go in the first position of each parentheses. Now I need to get the lasts, and the key word that I had written for this problem when I talked about my parentheses was add. This is what my lasts are going to need to do. My lasts are going to have to multiply to be the last number in this problem, which is 21. Keyword is add, so my lasts have to add to be the middle number in this problem, which I haven't looked at yet, which is 10. And the 2 numbers that do that simultaneously are 3 and 7, because 3 times 7 is 21, and 3 plus 7 is 10. And those are the numbers that need to go in my lasts. When the signs are both plus, it doesn't matter where you put the numbers. So it would be equivalently correct for this step to write x plus 3 times x plus 7, or you could write x plus 7 times x plus 3. Both of these are correct. There isn't one that's preferred over another. So you can't go wrong when the signs are both plus. If you get the correct lasts, it doesn't matter which parentheses you put them in. If I FOILed this out, this would FOIL out to be x squared plus 10x plus 21. But I want my answer to FOIL out to 3x squared plus 10x plus 7, which this won't do. So if you stopped here, it's not factored right. Bottoms up starts by multiplying. It ends by dividing. So for part C of the bottoms up method, so bottoms up has multiple steps, I'm going to divide the lasts by what I multiplied by. And in this problem, I multiplied by 3, so now I'm going to divide by 3 in just the lasts. And on this step, I'm going to reduce any fractions. For the fractions that don't reduce, I'm going to bring the bottom up. And that's the confusing part at first. So I'm going to reduce and bring the bottom up. So if I look at my two parentheses, depending on which parentheses I have first, I'm going to focus on this bottom one just because it's here for me. The first parentheses, 7 over 3 doesn't reduce as a fraction. Since the fraction doesn't reduce, I'm going to bring the bottom, which is the denominator, up. And up, it's going to go up in front of the first. So the 3 that was in the denominator of a fraction that doesn't reduce is going to be written to the left of the x. In the second parentheses, 3 over 3 is 1. The fraction goes away. There's nothing to bring up. I just reduce the fraction. And I claim I'm done. This is supposed to be the answer. Anytime I start with a problem that asks me to factor, I should be able to take my answer and FOIL it back out to get to the original problem. If you started with these parentheses, you'd have the same answer, but you'd have had x plus 1 first and 3x plus 7 second. So if you have your parentheses in a different order, that's completely fine. So I have the luxury now of checking. So I'm done with the factoring. I didn't have a greatest common factor to worry about. I got my signs. I did the bottoms up. Because bottoms up starts by multiplying, it produces something that's easy to factor that doesn't FOIL out to be the original problem. I have to undo that multiplying by dividing. If the fraction goes away, I don't have a bottom to bring up, but if the fraction remains, I have a bottom to bring up. I'm going to go ahead and check this. That's a step 4 that I don't generally always do, but if I have the time, then anytime you factor, you can check. So the original problem for number 1 is 3x squared plus 10x plus 7. And my answer, I claimed that this equals to 3x plus 7 times x plus 1. And this is the checking part. So this is step 4. Check. And this is optional, but it's not a bad idea to do. So I'm going to check by FOILing. I'm going to do my firsts. My firsts are a 3x times an x. The 3 just stays when I do the first. When I multiply the two x's, I get an x squared. Now I'm going to do the outers. The outers are 3x times a 1. Multiply two positives, I get a positive. I'm going to multiply the 3 and the 1 and get 3, and just leave the x alone. Now I'm going to do the inners. The inners are multiplying a 7 and an x. They're both positive, so I get a positive. I really can't multiply those, so I'll just leave them written next to each other as a 7x. And my lasts are 7 and a 1. They're both positive, so I get a plus sign. 7 times 1 is 7. And generally when you FOIL, the outers and the inners can be combined into a single term, and that's the case here. The 3x plus 7x will add up to be 10x. The 3x squared can't be added to a term that has an x to the first power, and the 7 can't be added to a term that has an x to the no x, or an x to the first power. If I look at my FOILing compared to the original problem, they're exactly the same, so my answer is correct. So I put a little check sign. What would be wrong to do would be to do this. This is a common mistake. If the instructions say factor, it doesn't mean factor and set the parentheses equal to 0. It would be wrong, and you're going to lose a couple of 2 or 3 points on a 5-point problem if you would have taken an extra step, and after you factored, if you just take the problem and set them equal to 0, bad. That's a bad thing. That's a wrong thing to do. You don't set your factors equal to 0 if the problem doesn't have an equal sign. And the original problem here, 3x squared plus 10x plus 7, the instructions said factor. There wasn't an equal sign, so it's completely wrong to do the algebra that I'm scribbling as I'm not talking about how to do it. It would be completely wrong to say x equal to negative 7/3 and x equal to negative 1. So this right here is a correct answer, which also could have been written as x plus 1 times 3x plus 7. This is a wrong answer. And I suppose on a 5-point test, it would be -2 or -3 if it's a 5-point question. That's a really bad error to make. The only time it's proper to take your answer and set each of the factors equal to 0 is if the original problem has an equal sign and the original problem is equal to 0. That's a huge deal. So I'm going to go through a few more bottoms up. In fact, I'll do each of the problems that I mentioned as I was talking about the signs, just to show you how to factor each one of those, and then I'll do a few more from the section. So for each one of the problems, I'm going to attack them the same way, and I'm going to factor each of these without having to deal with the number in front of the letter, which is the beautiful thing about bottoms up. So if I look at problem 6, was the second problem that I noticed the signs on. I know that when I go to factor this, my signs are going to be a couple of minuses. So with that first little page, I said if the signs are minus and plus, my parentheses minus and minus, and somehow the keyword is add. So I know that my parentheses are going to have signs that are minuses. It's hard for me to factor with that 5 in front of the x squared, so I'm going to start bottoms up. I'm going to multiply the 5 in this 12. I'm going to steal the 5 away from the x squared, and when I multiply 5 times 12, I get 60. So I'm going to change the last number to a 60. Notice the signs stay perfectly the same here. And so I'm not going to factor the original problem. The original problem is harder for me to factor than this modified problem. The modified problem, when I factor it, it doesn't give me the right answer, but then I just have to finish by dividing and bringing the bottoms up to get the right answer. So to factor this, my signs still are minus and minus. I'm going to take the x squared and split it between the parentheses. It's in the first position, so it stays in the first position. And now I need to work on my lasts. This 60 is going to be important because my lasts have to multiply to 60. And the keyword is add when the signs are the same, and they have to add to 17. And that's what 5 and 12 do perfectly for me. 5 times 12 is 60, and I'm adding, and 5 plus 12 is 17. I don't have to worry about the signs because I have the signs in, and when the parentheses have both plus signs or both minus signs, it doesn't matter where you put the numbers. I need to put a 5 in one parentheses for the last and a 12 in another parentheses for the last. It wouldn't matter if I put a 5 here and a 12 there, or if I put a 12 there and a 5 there. They're both equivalently correct. Neither one's better than another. I'm just going to put the 5 first and the 12 second. And the reason 5 and 12 is because 5 plus 12 is 17 and 5 times 12 is 60. That's the beginnings of bottoms up, but it's not done. If I FOILed x minus 5 times x minus 12 out, it would FOIL out to be x squared minus 17x plus 60. That's not the original problem. I want something to FOIL out to be 5x squared minus 17x plus 12. And this particular set of parentheses won't factor out to be that. I'll fix the problem like I did the last problem. I started off by multiplying by 5. Now I'm going to divide by 5 to fix. The first parentheses, the fraction reduces. 5 divided by 5 is 1, so I'm just going to write a 1. The second parentheses, the fraction doesn't reduce, so I'm going to bring the bottom up. By bringing the bottom up, the 5 is in the bottom or the denominator. I'm going to bring it up in front of the x. It's the first thing in that parentheses. And that's a correct answer. An alternate correct answer, if you would have written 5x minus 12 times x minus 1, that's equivalently correct. Since I have the time, I'm going to go ahead and check this. I'm going to check this version right here. I'm going to check by FOILing. My firsts are x times 5x. I leave the 5 alone, and the two x's multiply out to be an x squared. So the first gives me a 5x squared. The outers are an x times a minus 12. Positive times a negative is a negative. I just leave the 12 and the x next to each other. So I get a minus 12x. The inners are a minus 1 times a 5x. Positive times a negative is a negative. I multiply the 1 and the 5 and get 5, and I leave the x alone. And the lasts are a minus 1 times minus 12. Two negatives multiply out to be a positive, so I get a plus sign. 1 times 12 is 12, so I leave it plus 12. Generally, when I'm checking by FOILing, the outers and the inners can be combined together, and that's the case here. Because both the outers and the inners are negative, when I combine the outers and the inners to a single term, I'm going to add the numbers and keep the negative sign. So for my FOILing, I'm going to bring the 5x squared down. It can't be combined with the terms that have the x without an exponent. The 12 and the 5 are going to be added and be left negative. I'll get a negative 17x, and I bring down the plus 12. If I look at this problem, or that line compared to the original problem, it's exactly the same, so my answer is correct. So I'm done with this problem. If I do anything else, it's bad. This is the common mistake. It would be completely wrong, and you're going to lose points if you do this. If you go x minus 1 equal to 0, 5x minus 12 equal to 0. For the x minus 1, if you add 1 and set x equal to 1. For the 5x minus 12, if you add 12 and get 5x equal to 12, and divide by 5 and get x equal to 12 fifths, and you wrote down on your answer blank, instead of writing x minus 1 times 5x minus 12, if you wrote x equals 1 and x equals 12 fifths, it's going to be a minus 2 or a minus 3, and I'll decide on that before I start grading your tests. It kind of depends on how many points each problem is worth, and I don't know. But you're going to lose points. So the reason it's wrong to take the parentheses and set each parentheses equal to 0 is because the original problem doesn't have an equal sign. If I look at every problem in section 1.3, I don't see an equal sign in any one of those problems. If for any of those problems, if after I factor, I set the factors equal to 0, bad things will happen in terms of your grade. You're going to lose points. If you contrast that to the last section in the chapter, section 1.5, you'll notice all of the problems in section 1.5 have equal signs. If any problem starts off with an equal sign, that's when you're going to get numerical answers. So a problem like number 1 in section 1.5, my answer is going to be x equal to, actually 3 and x equal to negative 2. My answers are going to be numerical numbers. They're not going to be factoring. Not factors. The factoring is not going to be my answer. Physical numbers are going to be my answer. Whereas every problem in section 1.3, because there isn't an equal sign, my answer is going to have just a couple of factors, and that's it. If my answer has numbers without the factors, that's wrong. All right, so getting back to bottoms up. So that's 2 problems that I've done with bottoms up. And these are the easier kinds of problems. They're easier because I can't go wrong with my lasts. when I put my lasts in problem 6, I could have just as easily put the 12 first in the 5 second. My answer would be just as correct. Similarly, when I did problem 1, I put a 3 in the first parentheses and a 7 in the second parentheses. My answer would have been just as correct if I put the 7 in the first parentheses and the 3 in the second parentheses. So those two scenarios, in some sense, are kind because you can't put the lasts in the wrong parentheses. When the signs in my answers are both minus or both plus, it doesn't matter where you put the lasts in, they're going to work just fine. The next two problems, one parenthesis is going to have a plus sign, another parenthesis is going to have a minus sign, and these are the problems where it gets really picky in terms of the lasts. So the two problems that I thought to do, that I just noticed as I was looking at the problems, that are going to have one parenthesis with a plus and one parenthesis with a minus, are problems 12 and 10, and I'm doing 12 now just because I noticed it first. When I go to factor this, I told myself the signs need to be plus and minus. It could be minus and plus, that doesn't matter, but you need one parenthesis with a minus, one parenthesis with a plus. I usually do the plus in the first parentheses and the minus in the second. It wouldn't be wrong to have a minus than a plus. That's not a deal breaker. But what's going to be important is the number that gets attached to the plus and the number that gets attached to the minus. And you can put numbers in the wrong place. So when I go to factor this, I know I'm going to have one parenthesis with a plus and one parenthesis with a minus. I'm going to start my bottoms up again. I'm going to multiply the 4 by this 15. Not worrying about the signs, I'm just going to leave the signs as they sit. And 4 times 15 is 60. So I'm going to rewrite the problem as x squared plus 4x minus 60. And this is where I'm going to have to be careful with my lasts. My lasts are going to have to be I have to be careful with my lasts. My lasts are going to need to multiply to that last number 60. They're going to subtract to the middle number, which is 4. And because this 4 is positive, the bigger of the two numbers has to be positive. So I'm going to pick my last out. I'm going to find two numbers that simultaneously multiply to 60 and subtract to 4. And those are 15 and 4, because 15 times 4 is 60. And, whoops, that's not right. I just lied to you because I'm messing up. 15 minus 4 is 9. That wouldn't be good. How about 10 and 6? 10 times 6 is 60, and 10 minus 6 is 4. And 10 is the bigger number. I'm going to put a positive with the 10 and a minus with the 6. If you put the positive with the 6 and the negative with the 10, it won't FOIL out right. So as I go to factor this line, x squared plus 4x minus 60, I have my signs in. I'm going to split the x squared between the two parentheses. X times x will give me my firsts. And 10 times 6 is 60. 10 minus 6, because I have to subtract to be the middle number, is 4. And the bigger number, which is 10, needs to be tagged to the positive. The smaller needs to be tagged to the negative. That would FOIL out to x squared plus 4x minus 60. Doesn't FOIL out to be the original problem. To FOIL out to the original problem, because I started off multiplying by 4, I need to divide by 4. This is a little bit different than the last two problems, because each of these parentheses has fractions that are reducible, but fractions that don't go away. That's okay. What I'm going to do for bottoms up is I'm going to reduce the fractions the best I can. The first fraction, 10 over 4, reduces to 5 halves. The second fraction, 6 over 4, reduces to 3 halves. So I reduced my fractions. Fractions didn't go away, but they did reduce. Now I'm going to bring the bottoms up. So if the fraction reduces but doesn't disappear, you're still stuck doing a bottoms up, and you could have two bottoms to bring up. This is going to give me my answer. I'm going to put the 2x in front of the 2 in front of the first x, the 2 in front of the second x, and get 2x plus 5 times 2x minus 3. I'll go ahead and check again although checking is completely optional if you're confident in your answer. For checking here, I'm going to do my firsts, and I'll do 2x times 2x and get 4x squared for the first. The outers are 2x times minus 3. Positive times the negative is a negative. I multiply the 2 and the 3, and I get a minus 6x. The inners are positive 5 times 2x. Positive times a positive is a positive. I multiply the 5 and the 2 and get a 10. I leave the x. The lasts are 5 and a negative 3. Positive times a negative is a negative. I multiply the 5 and the 3 and get 15. Just like the first two problems, I'm going to combine those inners and outers into a single term. The 4x squared is going to stay alone. Because the numbers in front of the x's have opposite signs, I subtract and take the sign of the larger. So I'm going to take 10 minus 6. Because the 10 is bigger, the sign gets to be plus. 10 minus 6 is 4, and I leave the x and bring down the minus 15. If I compare that FOIL to the original problem, it's perfect. So my answer is correct. If in my original problem I messed up and put a plus 6 and a minus 10, if the 6 had the plus in front of it, then I'd be wrong. So I'll show you what would happen. This would be a common mistake. So when you're dealing with parentheses that have opposite signs, so this would be a common error. This is going to be wrong. If you started off, you did 4x squared plus 4x minus 15, and then you did your bottoms up, and you knew the signs had to be plus and minus, and you knew that the last had to be 10 and 6. If you put the 6 with the plus and the 10 with the minus, bad things are going to happen. Your answer is not going to check properly. When I did this, I put the 10 with the plus, the 6 with the minus, because the bigger number needed to be positive because this 4 was positive. If I would have done the numbers wrong, had the right numbers but in the wrong place, this is what would happen. I would split the x's up, put my last in. I started off multiplying by 4. I'll divide by 4. Reduce the fraction to 3 halves. Reduce the second fraction to 5 halves. Bring my bottom up and get a 2x plus 3 and a 2x minus 5. When I go to check that answer, which is a lot like my answer but not exactly the same, because you'll notice that I have a 2x. With the plus, I have a 5. With the minus, I have a 3. This has the roles of the 5 and the 3 reversed. Because it has the roles of the 5 and the 3 reversed, it's going to give me the wrong middle number. But I'll check it just to show you that that messes me up. So if I was checking this, I do my firsts, which are 2x times 2x, which is 4x squared. The outers are 2x times minus 5, which is a minus 10x. The inners are 3 times 2x, which is a positive 6x. And the last, 3 times minus 5 is a minus 15. And generally when I FOIL, it's just the outers and the inners that can be combined. That's the case here. I'm going to bring down my 4x squared. Because the outers and the inners have opposite signs, I know I'm subtracting the numbers in front of the outers and the inners. And when I do the subtraction, I take the sign of the bigger number. This minus 10 and this positive 6 are going to give me a minus 4x. Then I bring down the minus 15. If I look at this foiling compared to my original problem, it's almost right. It's not completely right because it has the wrong sign in front of the middle term. So it's hugely important when you're factoring, when you have one parenthesis that has a plus and another parenthesis that has the minus. It's important to know which number is proper to put with the plus and which number is proper to put with the minus. If the parentheses have both pluses or both minuses, you can't go wrong. You can put the numbers in either parentheses and they'll work just perfect. The last number that I hinted at the beginning was problem 10, so I'll go ahead and do it. And this was another situation where I was going to have one parenthesis with a plus and one parenthesis with a minus. The difference between the problem that I just did and in this problem is the bigger number has to be negative. So my lasts are going to have one positive and one negative. In this particular problem, my bigger last is going to get the negative. Whereas in the last problem that I did, because this sign is 15, the sign of the 4 is positive, the bigger last is going to get the plus. So in each one of the problem that I just did, problem 12, and this problem number 10, each of the parentheses has 1 plus and 1 minus. When you have 1 plus and 1 minus, you can go wrong. And when you get your last, one of the last is going to be bigger than another. And the bigger has to get the right sign. If this first sign is minus, the bigger last has to be minus. If this first sign is plus, the bigger last has to be plus. This is when I put a positive 10 and a negative 6. 10 is bigger than 6, the bigger the last gets the plus. When I figure out what my lasts are in this problem, the bigger the last is going to get the negative. I'm going to bottoms up this again because it's hard for me to factor the problem how it sits. So I'm going to multiply the 8 and the 5 and get y squared minus 6y minus 40. And my lasts, they have to multiply to 40. They have to subtract to 6. And the bigger has to be negative. I know that 10 times 4 is 40. 10 minus 4 is 6. And because of this minus, the 10 is bigger. The bigger number needs to get the negative. When I go to do my lasts, the 10's going to get the negative. The 4's going to get the positive. The first, I'm just going to split the y squared evenly between the two parentheses as a couple of y's. That would be the correct way to factor y squared minus 6y minus 40. It's not the correct way to factor the original problem. To factor the original problem properly, I need to divide by what I multiplied by. I started off multiplying by 8. I'm going to divide by 8. Each of the fractions reduces, but neither of the fraction goes away. First fraction reduces to 1/2. The second fraction reduces by 2 to 5/4. Bring my bottoms up. And I'll get my answer to the original problem. The original problem is going to factor into 2y plus 1 times 4y minus 5. It would be correct if you had written 4y minus 5 times 2y plus 1. It's not a deal breaker if you have your parentheses in a different order, but it would be wrong if you had 2y plus 5 and 4y minus 1. The 2y and the plus 1 need to go together. The 4y and the minus 5 need to go together. If you had the 5 in the first parentheses, the 1 in the second parentheses, it wouldn't work right. Again, I'll check this one, but it might be the last one I check. Checking gets to be kind of a nuisance, so I'll check by foiling. Firsts are 2y times 4y. 2 times 4 is 8. Y times y is y squared. Outers are 2y times minus 5. Positive times a negative is a negative. I multiply the 2 and the 5 and get 10, and I leave the y alone. The inners are 1 times 4y. Positive times a positive is a positive. 1 times 4 is 4, and I leave the y. And the last are positive 1 times a negative 5. Positive times a negative is a negative. 1 times 5 is 5. So the beginnings of my foiling, I get 8y squared minus 10y plus 4y minus 5. The outers and the inners will combine together into a single term. Because the numbers in front of the outers and the inners have opposite signs, I subtract and take the sign of the larger. 10 minus 4 is 6. The 6 is going to be negative because the bigger number is negative. And I bring down the minus 5. I look at this and compare it to the original problem. It's factored perfectly. So hopefully you're starting to get the hang of bottoms up because it's a really nice factoring strategy. If you didn't already know how to factor problems that have a number in front of the squared, bottoms up is a great way to go. If there's not a number in front of the squared, this problem just said y squared minus 6y minus 5, then I could went straight into my two parentheses. I wouldn't have to do the multiplying part. I only do the bottoms up part when there's a number in front of the square term. If there's not a number in front of the square term, there's nothing to multiply by. I can go straight into my factoring. That's what section 1.2 is. The difference between section 1.2, where you wouldn't see a number in front of the square term, and section 1.3, where you do see the number in front of the square term, is just that number. And when you have that number in front of the square term, just multiply it through and do bottoms up. All right, let me do a couple more problems from the first section. Maybe one or two, and then do some of the ones in the last grouping of problems, 17 through 24 as well. So I hadn't done, done 1, 6, 10, and 12. So I guess I haven't done 8, I haven't done 14. Let me do 14. 14's harder because you get 1 plus and 1 minus. So when I go to factor 8y squared minus 5y minus 3, I can put my parentheses down. My lasts are going to have different signs, and the bigger last is going to get the minus because that minus right there. So when I go to figure out my lasts, there is one parenthesis with a plus, one parenthesis with a minus. There's going to be two numbers to plug in. I have to know which one gets attached to the minus. The bigger number is going to be minus. If that was a plus right there, if I was factoring 8y squared plus 5y minus 3, the signs are still going to be plus and minus, but the difference is the bigger last for this one would be positive. But that's not the problem, so I'm not going to do it. So I'm going to start bottoms upping this. I'm going to multiply the 8 into the 3 and get y squared minus 5y minus 24. Signs are down already. I split my y between the first two parentheses for my firsts. My lasts need to give me that 24 and that 5. My lasts are going to have to multiply to be the 24, subtract to be the 5, and the bigger has to be negative. I know that 8 times 3 is 24. 8 minus 3 is 5. So 8 and 3 are their proper lasts. The bigger of the lasts needs to get attached to the negative. So the 8's going to go next to the negative. The 3's going to go next to the positive. I started off multiplying by 8, so I'm going to divide by 8. First fraction, 3 over 8 doesn't reduce. I just bring the bottom straight up and get an 8y plus 3. Second fraction, the 8 over 8 reduces to 1. I'm not going to bring a bottom up when the fraction reduces and goes away. The answer to 14 is going to be 8y plus 3 times y minus 1. It wouldn't be wrong to say it y minus 1 times 8y plus 3. That would be equivalently correct, just as long as the minus 1 goes with the y and the plus 3 goes with the 8y. Could FOIL that again to check it. So I did that kind of fast. The nice thing about being able to watch the videos is you can pause and rewind if I start going a bit fast. It's never a bad idea. If I write down a problem, it's never a bad idea just to pause, do the problem, and then watch me do it to see if you've done it right. That's probably better than just watching me do it, because it's a lot easier to watch my work and think you understand it than it is to actually figure out the problem by yourself. And figuring out by yourself is what you need to do for the tests. So let me do 16, and then I'll get into the second group of problems. The 16, in some sense, is a trick problem. I'm going to emphasize that there's a 1 implied in front of that x in the middle. The original problem, 16, doesn't have a 1 there. When you have an x written without a number in front of it, there's an implied 1. I know that my signs are plus and plus from the template that I gave earlier. Let's start my bottoms up. I'm going to multiply the 7 into the 3 and get 21. I'm going to rewrite this as x squared plus 1x plus 21. I know I'm going to split the x's between the firsts, so the x squared gets split up. And then my lasts need to multiply to 21 and add to 1. Well, 1 times 21 is 21, but 1 plus 21 is 23, so that's not good. 3 times 7 is 21, and 3 plus 7 is 10. That's not good. And I don't think 21 has any other factors that I can think of. This is not a good thing, because there aren't a pair of factors that simultaneously multiply to 21 and add to 1. When you can't find lasts that work, it doesn't factor, and the correct answer for this is that it's prime. So a polynomial, a trinomial that you can't find lasts to do what they need to do, it's just prime. So I couldn't find a pair of numbers that simultaneously multiplied to 21 that added to 1. Since those didn't exist, the whole thing doesn't factor, and it's just prime. Okay, so let me do 2 or 3 of the bottom group. I should definitely do 24 because it has a negative to factor out. 18 is as good as any, I guess. The checking's a little bit trickier on these. Each of the problems between 17 and 24 have a greatest common factor. If you don't factor out a greatest common factor, the bottoms-up method doesn't work. It doesn't give you the right answer. The bottoms-up method requires you to pull out the GCF first. And that's what I'm going to do for this problem. First thing I'm going to do is I look at the 15, the 36, and the 21 and realize each of those numbers is divisible by 3. So 3 is my greatest common factor. I'm going to write a 3 in front of a parentheses and then divide each of the numbers in the original problem by 3 and leave the sign. So 15 divided by 3 is 5. I'm not going to take the n squared away. I'm going to leave it. I'm going to bring down my plus sign. 36 divided by 3 is 12. I'm going to bring down my n. Then I'm going to bring down my plus sign. 21 divided by 3 is 7. So I get 3 times 5n squared plus 12n plus 7. The 3 is going to be part of my answer. But I'm going to ignore it now. It will not affect, I'll say impact because I'm not sure which effect is right, the rest of the factoring. So what I need to do now is factor this 5n squared plus 12n plus 7, which I'm not good at factoring, so I'm going to take this 5n squared, get rid of the 5, incorporate it into the 7. And I'm going to factor n squared plus 12n plus 35. So the 3 is going to be part of my answer. It's not going to impact the factoring. What I need to factor is 5n squared plus 12n plus 7. The 5 in front of the n squared makes this hard to deal with, so I'm going to do bottoms up. Multiply the 5 and the 7 and get 35. I'm going to leave this 3 alone, get my signs, which are a couple of pluses, split the n squared between the two parentheses as a couple of n's, and then work on my lasts. My lasts have to multiply that last number 35. They need to add to the middle number 12. And the beautiful thing is parentheses and they have the same signs. I can't go wrong with my lasts. They can go in either parentheses and I'm okay. And 7 and 5 will do perfectly for my lasts because 7 times 5 is 35. 7 plus 5 is 12. And in one parenthesis you need a 7, in another parenthesis you need a 5. It absolutely is correct if you put a 5 in the first parenthesis and a 7 in the second parenthesis. Not done with my bottoms up. I started off by multiplying by 5. I'm going to divide by 5. And this will lead me to my answer. The original problem will factor. The common factor of 3 is going to be in my answer. The first parenthesis, the fraction doesn't reduce, so I bring the 5 up in front of the n and get a 5n plus 7. And in the second parenthesis, the 5 over 5 is 1. I claim that this is the right answer. An equivalently good answer would be 3 times n plus 1 times 5n plus 7. That would be okay too. It's correct. I will show you that it is correct. The checking is a little bit trickier with a common factor, so I'll show you how to check it just in case you have the desire. When you factor, you don't always have to check, but it never hurts to check. So my answer is 3 times 5n plus 7 times n plus 1. And the original problem is 15n squared plus 36n plus 21. Better be the case that my answer foils out to be the original problem. Need to do this properly. I'm going to work from left to right. The first thing I'm going to do is multiply a 3 into the parentheses that it's attached to, not into the second parentheses. Once I multiply the 3 into the first parentheses, I'm done with the 3. So I'm in the first parentheses, I'm going to multiply a 3 and a 5n and a 3 and a 7. When I multiply the 3 and the 5n, I get 15n. I bring down the plus sign. When I multiply the 3 and the 7, I get 21. And I'm going to bring down that second parentheses that I haven't dealt with. Now I'm ready to FOIL. I've taken care of the 3. I have two parentheses next to each other that need to be FOILed. The first are 15n times n, and I leave the 15. When you multiply n times n, you get n squared. The outers are 15n times 1. They're both plus, so I get a plus sign. I multiply the 15 and 1 and get 15 and leave the n. The inners are 21 times n. They're both positive, so I get a plus sign. I just leave the 21 and the n next to each other. And the lasts are 21 times 1. They're both positive, so I get a plus sign. And 21 times 1 is 21. And 15n squared I bring down. 15n and 21n, I add the 15 and the 21 and get a 36, and I leave the n, and I bring the 21 down. So that answer will FOIL out perfectly. My answer, if I FOIL it properly, will equal the original problem, so my answer is correct. So the answer of 3 times 5n plus 7 times n plus 1, or 3 times n plus 1 times 5n plus 7, will both FOIL out to the original problem, so my answer is correct. It would be wrong to have numerical answers. So if somewhere in your work for this problem you said n equal to -1, that's wrong. You don't get numerical answers. You don't get a letter equal to some number unless the problem starts off with an equal sign. Since this problem didn't have an equal sign to start, it best not have numerical answers. So I'm going to do 20 and 24 and then get out of here. Hopefully I haven't done a horrendous job and made a ton of errors. So 20 gives me 8x cubed minus 22x squared plus 5x. There's not a common number factor because there isn't a number that divides evenly into 8 and 5 other than 1. But each of the terms has an x, so I need to factor out a common factor of an x. So every problem in the bottom grouping has a common factor that needs to be dealt with. On problem 20, that common factor is an x. When I pull out my common factor, if that common factor doesn't have a sign with it, the signs are going to stay the same. The original problem had a minus first and a plus second. My answer is going to have a minus first and a plus second. I didn't change the 8, but I took an x away. I started with 3 x's next to the 8. I took 1 away, so I'm left with 2 x's. I did nothing to the 22, so I'm going to leave it alone. I had 2 x's next to the 22. I took 1 away, so I'm just left with 1. For the 5x, I didn't do anything to the 5. I'm going to leave it, but I took its x away. So the start of this problem is factoring out the common factor of x. When you factor out the x, you're left with 8x squared minus 22x plus 5. This x is going to be part of my answer, but it's not going to impact the factoring anymore. I'm going to start my bottoms up by multiplying this 8 and this 5 to get a 40. I stole the 8 away from the x squared. I'm going to leave the x squared, not changing the signs when I do bottoms up. So I brought the minus and the plus sign down again. I multiplied the 8 and the 5 to get 40. This gives me x times x squared minus 22x plus 40. A little bit trickier to factor. I should be able to go to my template and know what my signs are. My signs for this have to be minus and minus. I know that my firsts, I'm going to split the x squared between the two parentheses and get a couple of x's. And my lasts are the tricky part. They need to multiply to the last number 40. They need to add to the middle number 22. And 2 times 20 will do that perfectly. Because 2 times 20 is 40 and 2 plus 20 is 22. Because the signs are the same, I can't go wrong. I could put the 2 in the first parentheses, or I could put the 2 in the second parentheses. They're both equivalently correct. I'm going to go ahead and put a 2 in the first and a 20 in the second. But if you had x minus 20, then x minus 2, that would be completely fine. This x, you notice it remained, didn't get impacted by any of the bottoms up factoring. I started off multiplying by 8. I need to divide by 8. Not going to divide the x out in front of the parentheses by 8 because that isn't impacted by the bottoms up factoring. First fraction reduces. I'm going to have to reduce it. 2 over 8 is 1/4. Second fraction reduces, but the fraction doesn't go away. I reduce each of these by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. Bring my bottoms up, leave the common factor of x, and I'm going to get my answer, which also can be checked, but I'm not going to check it. I'm going to leave that x out front. I'll bring the 4 in front of the x and get a 4x minus 1. I'm going to bring the 2 in front of the x and get a 2x minus 5. As long as your answer has these 3 pieces, the order's not a deal breaker. So had you written x times 2x minus 5 times 4x minus 1, that's equivalently as nice of an answer as x times 4x minus 1 times 2x minus 5. I could check it the same way. The first thing in my checking, if I tried to check it, I'd multiply the x through this parentheses and get 4x squared minus 1x, and then I'd go into foiling. But checking sometimes takes more work to do than the problem itself, and that might be the case here. So last problem I'm going to do is 24. Hopefully that will give you a good enough review to be able to do all the odd problems in this section. This kind of factoring is a big deal in Chapter 2, as well as if you take Math 150, 151, or 187 next, that kind of factoring comes up, more than you care for it to come up. It really does. So you have to get comfortable with that kind of factoring. Of each of the problems in this grouping from 17 through 24, only 2 of them start off with a negative. 23 does and 24 does. When the first term has a negative in front of it, when you pull out your common factor, you pull a negative with your common factor. The common factor in this problem is just a 2 because 4, 18, and 20 are all divisible by 2. But instead of writing just a 2, I'm going to write a negative with that 2. So I'm going to pull out my common factor, which is a 2, but because the first term is negative, I'm going to put a negative with the 2. As we learned, yes, in section 1.2, anytime I factor out a sign, a negative sign, I need to change the signs. So immediately, when I noticed that I needed to factor out a negative because the first term was negative, I decided to change the sign so I'm not worried about my signs. I factored out a 2. I'm just going to divide each of the numbers by 2. 20 divided by 2 is 10. I leave the x squared. 18 divided by 2 is 9. I leave the x. 4 divided by 2 is 2. So I need to factor negative 2 times 10x squared minus 9x plus 2. This negative 2 is going to be part of my answer but not impact the factoring anymore. Inside the parentheses, I'm going to factor by bottoms up, which means I'm going to multiply the 10 and the 2 and get x squared minus 9x plus 20. That negative 2 that's part of my answer is not going to impact the factoring anymore. The signs here being minus and plus tell me I need a couple of minuses for my parentheses. I split the x squared between the two parentheses and get a couple of x's. And my lasts have to multiply to that last number 20. They have to add to the middle numbers 9. And the beautiful thing about this is I can't go wrong with my lasts. They're going to be 5 and 4 because 5 times 4 is 20 and 5 plus 4 is 9. You could do a 4 first and a 5 second or 5 first and a 4 second. That won't slow you down regardless of which one of those you choose to do. They're both equally correct. So if at this step right here you had a 4 first and a 5 second, that doesn't matter because when the parentheses have the same signs, you're not in a bad position. You can't really put the numbers in the wrong positions. I'm going to divide by the 10 that I multiplied by. Both the fractions are going to disappear now. They're not going to disappear. The first fraction is going to reduce to 1/2. The second fraction is going to reduce to 2/5. So 5 over 10 I reduced each by 5. 4 over 10 I reduced each by 2. Double bottoms up now. I bring the 2 in front of the first parentheses and get a 2x minus 1. A 5 from the first parentheses gives me a 5x minus 2. I claim that this is my answer. If I want to, I can check. I'm going to go ahead and check. So as long as you have these 3 pieces, a minus 2, a 2x minus 1, and a 5x minus 2, the order is not a deal breaker. So if your answer looks like minus 2 times 5x minus 2 times 2x minus 1, that's completely okay. It takes me a minute to check this, and this is a trickier one to check, so I might as well check it. So my answer that I came up with is negative 2 times 2x minus 1 times 5x minus 2. And my goal is to multiply that out to get the original problem, which is negative 20x squared plus 18x minus 4. Just like I checked before, I'm going to do the multiplication to get the common factor back into the parentheses. So I'm going to go minus 2 times 2x and minus 2 times minus 1. When I multiply the minus 2 times minus 2x, I multiply the minus 2 times the 2 and get a minus 4, and I leave the x. When I multiply the minus 2 times the minus 1, I get two negatives that multiply out to be a positive. 1 times 2 is 2. Now that common factor is gobbled up in the first parentheses. I'm done with the common factor. I'm going to finish up my checking by foiling. My foiling is going to have me do the first, which is a negative 4x times a 5x. Negative 4 times positive 5 is negative 20. I multiply the x's to get an x squared. My outers are negative 4x times a negative 2. Double negative multiplies to be positive. I multiply the 4 and 2 and get 8. I leave the x alone. My inners are a positive 2 times a positive 5x. There are a couple positives, so I get a positive. I multiply the 2 and the 5 and get a 10. I leave the x alone. My last are a positive 2 times the negative 2. Positive times the negative is a negative. 2 times 2 is 4. So my foiling gives me negative 20x squared, which I see in my original problem. A positive 8 and a positive 10x. When I add those and combine those together, because they're both positive, I get an 18x and a minus 4, which I see in the original problem. Because when I multiplied out my answer, I get the original problem, my answer is correct. So every single problem in section 1.3, after you factor it, if you have the patience and the desire, you can multiply out. If you multiply out correctly, you should multiply out to be the original problem. For me, this is the hardest kind of factoring there is to do. So if you get this kind of factoring down, then you can almost not do poorly on this test, because this is the chapter 1 test. More points are lost on section 1.3 factoring than any of the other sections. So if you're getting this down, you're doing really well. When we factor in section 1.4, we're doing squares and cubes, and hopefully I do a decent enough job that those aren't so tricky, but they're slightly tricky, but generally I do a good enough job that those aren't the worst things on the test. So hopefully this bottoms up. If you didn't already know how to factor problems that have numbers in front of the square terms, hopefully this bottoms up method is a thing of beauty, and now you know how to factor something that you maybe didn't before. And if you learned a method before, maybe you like this method better. Well, hopefully I didn't make too many mistakes. So if you're watching this video and you start wondering, what the heck did I do there? That number seems wrong. Let me know, because I did this video completely by myself, not a single person in the room. I just sat here and talked to myself, and it's highly probable that I make a mistake, because generally when I write a key for my test, I never get 100% of my own tests. So there's a large chance that there's an error somewhere in my work. So if you find it, let me know so I can point it out. Thanks.